the other point is we were talking about pure substance. Let's try to see these things separately. So we have in terms of chemical elements, we can say tin, sulfur, and diamond, like pure chemical elements. In terms of compound, we can take sugar, water, and baking soda, like pure substance. And we can take in terms of crystals, salt, protein crystals, and copper sulfate crystals. So these are as an example for pure substance in terms of chemical elements, compound, and crystals. So let's see phase of a pure substance. Let's say this one was when it was solid, right? This one when it starts to become vapor. So this graph is shows phase of pure substance. We have temperature and we have heat input here, and we have point A here and we have point A here. At this point, this element is in solid state, right? So we will go to until superheated process. So from A to B, we call this one solid warming process, from A to B. And after this element reaches at point B, it becomes saturated solid. And then if you see from B to C, which is at 1 atmospheric pressure, in solid to liquid transition, we call this melting or fusion process. And from C to D at the same time at 1 atmospheric pressure, we call this liquid heating process, like the liquid heating process. And at point D, this one is saturated liquid state. Saturated liquid state. And from D to E, which is liquid and vapor, at 1 atmospheric pressure, vaporization process. And then at point A, this one is saturated vapor state, saturated. But from E to F, this one is what? Superheated process, superheated process. So this one is really like a process of phase, like what we call phase of pure substance. So from B to C, we can say this one is latent heat of fusion, and from C to D, this one is sensible heating. From D to E, this one is latent heat of vaporization, and from E to F, this one is heat of superheating. So we can say at room temperature and pressure, copper is solid. An example of this, copper is solid, mercury is liquid, and nitrogen is a gas at room temperature. Like this one, you can take as an example for this what we call for this slide we are talking about. So let's carry on. Now let's see a property of a system. Any characteristic of a system is called a property. Any characteristics of a system, we call it a property. So we have mass, volume, temperature, pressure, and density. So we call two kinds of properties, extensive and intensive property, but we will see them here, down here. We have properties of matter. So the first question is, are these properties determined without changing the identity of the substance? If yes, we call this physical property, but if we change the identity of the substance, we call this no. So what kind of process do we have? Chemical process, and what we call chemical property and physical property. This one is we have to change the identity of the material. This one is we don't change the identity of the material, physical property. So in chemical properties, how does the substance to reaction to the presence of air, acid, base, water, or other chemicals? And in physical properties, we also have to ask another question that goes like this: does the properties depend on amount of substance? Does it depend on amount of substance? If yes, we call them extensive physical property. If no, we call them intensive physical property. If it doesn't depend on the amount, we call it intensive, like color, melting point, boiling point, and density. But extensive property, they depend on amount of a substance. We call them mass, volume, length, and shape. So in detail, we can take intensive property and extensive property. Extensive properties are in energy, entropy, Gibbs energy, length, mass, particle number, number of moles, volume, electrical energy, and weight. It really depends on the amount of substance. But intensive properties are chemical potential, concentration, density, ductility, elasticity, hardness, melting point and boiling point, pressure, specific energy, specific heat capacity, specific volume, specific observation maximum or insolation temperature, and viscosity. These are example of intensity property. So what I want you to have in your mind is like extrinsic properties they depend on the amount of a substance. Intensity properties, they don't depend on the amount of a substance. And also physical properties are property that we get without changing the identity of the substance, but